Welcome back. We're in 56 Part C, and we're going to talk about systems of inequalities. So remember that the graph and equation divides the set of all points. So whenever we graph this linear equation, it divides the set of all points. So the set of all points, you have the line itself that is equal to the linear equation, but then above we have the set of all points that is going to be greater than our equation, where the y value is greater than the y value of the line. And then below that line, we have the set of all points where y is less than the value of that line. So remember how we used to identify, we were given an equation, a linear equation with an inequality, and we were told to identify first we had to find the line and then identify which part of the graph was the value that was given to us. We had to select which one it was. Here we have illustrated a line, y is equal to negative 1/2 x minus 1. So that is the green that is written here. And then our greater than values, y is greater than negative 1/2 x minus 1, is the area A that is above the line. And B is the less than values, the area below the line. So we, by default, then began understanding that if it said greater than, it was above. It was all the values above that point on y that was also above the line. And then the negative, or the values below that on the y-axis, and all the points in the area that corresponded was for less than. At one point when we first began, we would test for a point. We would select a point, like we would take 1, 1 right here in A, and we would test it and see if it was true. And we would say, okay, our point is 1, 1. So 1 is greater than negative 1/2 times 1, because that's the x value, minus 1. So if 1 was greater than this, so this would be 1 times this, so that would remain negative 1/2 minus 1. So that would be 1 is greater than negative 1.5. And it is. 1 is greater than negative 1.5. So we could prove that this statement was true by subbing in there. And then we would turn around and we would prove the other was true. So for instance, if I pick a point here, let's pick negative 1, negative 3. So here's our point, negative 1, negative 3. And I'm going to prove that B is true with negative 1, negative 3. So I have negative 3 is less than negative 1/2 times negative 1 minus 1. So negative 3 is less than a positive 1/2 minus 1. So that would be negative 3 is less than a negative 1/2, which is true. Negative 3 is less than a negative 1/2 because it's further, or it's to the left on the number line. So it is less than a negative 1/2. So we were able to just pick points and prove them. So we're going to start adding. In Algebra 2, we would add another line, and we have to pick which areas that were created. Say, for instance, we added a line here. Then we would have 2 more sections. We would have a C and we would have a D. And then we would have to pick a point in here and pick a point in here and see if it was also true for the conditions we were given. And sometimes we would have more than one condition, and it had to be true for both of those conditions before we could highlight that area. So that was just a refresher on what we had done previously. Well, now we're going to do the same thing, except now we are going to add in something other than a line. We're going to add in parabolas. When we add in a parabola, we have this area that is A. Let me back up. All right, so we have this area that is A, and if I add a parabola to this, I'm just going to put it right here. Then what happens is we get this section that is above the line A, a section below the line B, but then we also get a section here, C, that is both above the line and inside the parabola. And then we get a section D that is below the line and inside the parabola. And then we get a section E. Actually, E would not be there. We would have section E, which is on the other side of the parabola, because remember, these go on indefinitely. And section E would be below the line and outside of the parabola. Everything outside of the parabola above the line is contained in A. So that's why we would not indicate it. So we have 5 sections there. So we would have to evaluate and understand each one of them in order to identify them appropriately. So let's do a practice problem that does that. All right, so I have one correction to make on the illustration that I just showed you. Remember I said you had an area that was outside of the parabola, E? That would not be E. That would be combined with area B, the one per 4. So the 2 areas below the line and outside the parabola, that's going to be together. Those 2 are going to be together. You have inside the parabola and you have outside the parabola. And then you have above the line and you have below the line. So this is C. It's below the line and outside the parabola. This is below the line and outside the parabola. So if you highlighted this side, if this was the area you were looking for, you would also have to do this side. So it's not a separate area unto itself. And I knew that, but I forgot because I am old. So just a side note, in case you didn't realize that from looking at my wrinkles. So let's begin with our first problem. So here we have the line and the parabola in this graph, in this figure. They divide it into 4 areas. Like I said, we have above the line and we have below the line. We have inside the parabola, above the line, and inside the parabola, below the line. So it's not just above the line and below the line anymore. It is also inside or outside of the parabola. So those are our 4 different areas that we have. So our question is, which region contains the coordinates of the points that satisfy the given system of inequalities? And here's our given system of inequalities. We have, and here is our system little bracket. Looks like somebody's face profile. We have y is greater than or equal to 1/2 x minus 4. And we have y is greater than or equal to negative x squared plus 4x minus 1. So just looking at these, we know that y, this is the line, and this is the parabola. Because we've worked with these equations enough to know the difference between the 2. So we know that the line is going to be included in the inequality because it says or equal to. And the equal to part is the line. So you draw a solid line whenever you identify which section of the graph meets these qualifications or these characteristics. And this says y is greater than, it's greater than and equal to the line. And y is greater than or equal to, so we know everything above the line satisfies this, right? So we can write above the line would be A or B. It's either A or B. So now we have to figure out if this is included. Is this part of the, is B satisfying this right here? So all we have to do is pick a point inside of B. So I'm going to pick this point right here, 2, -1. So -1 is greater than or equal to negative, and this is positive 2 squared plus 4 times 2 minus 1. 2 squared would be 4, so it's -4 plus 8 minus 1. So -1 is greater than or equal to, that would be a positive 4 minus 1 would be 3. So this is not true. So this area does not satisfy this equation. So it has to be the areas outside of the parabola that makes the equation true. So let's pick a point outside. Let's pick, I don't know. Let's pick just a point on the line. 1, 2, 3, 4. Let's do 5. Let's pick that point. And this is 0, 5. So I'm going to do it for both of these. We know it's true for the line. I'm just going to check it again just to make sure. So y is greater than or equal to 1/2 x minus 4. And then y is greater than or equal to negative x squared plus 4x minus 1. Just making sure I don't make any mistakes in transferring the equation down. All right, now I'm going to sub in my 0.05. So 5 is greater than or equal to 1/2 0 minus 4. 5 is greater than or equal to -4. So that is true. So it's true for the line. Let's see if it's true for the parabola. 5 is greater than or equal to -0 squared plus 4 times 0 minus 1. So that's going to be 5 is greater than or equal to 0 plus 0 minus 1, -1. True for that one also. So A is the area that we want to use. It's not going to be B. So the area above the line that satisfies both of these equations is going to be A. And so A would be the area that we would highlight or we would fill in. And we would also include the line. So whenever we draw this on our graph, we would make a solid line for the for this line, and then we would make this solid line for the parabola because it would include this parabola line as well. Just the line, not this bit on the inside. See if I can erase just this little purple bit. It lets me do just a little bit, but not very much. There we go. All right, so that would be the area that we shaded. That would be the solution, is area A. And what I may do in the system is give you a graph with A, B, C, or D in the illustration, and then you just have to tell me which area or areas. That way you don't have to graph this on Jupyter because it could be very difficult to do all of this, to graph it and all of this. So I'll just give you the illustration of the graph and label it A, B, C, or D, and then you will tell me which ones meet both conditions. I think that'll be, then the system can self-grade that. It'll be a lot easier. So that's how I want you to respond. Okay, so we have one more. Let me set it up. So here we have example problem 56.6, and we are given y is greater than or equal to x squared plus 4x plus 2. And here's that parabola. And notice we have the or equal to, so that is a solid line. So those points are included in whatever solution set we find. And then we have y is less than negative x plus 1, and those points are not included in that's why I have the dotted line here for that line. They're not included in whatever the solution for these two systems of equations are. So based on the inequality that is given, y is greater than x squared plus 4x, I believe that it is going to be inside the parabola and above the parabola, right? It's going to be inside because this is greater than, so it's going to be above the parabola line. So that's going to be inside of it. But y is less than negative x plus 1 tells me that's going to be below the line. So my hypothesis is that it is going to be section C. So I'm going to pick a point in C. I'm going to pick this point right here because it's well within the C area. And I'm going to test both of these for it. And just to make sure, I'm pretty confident it's C, but I'm going to double check by testing my points. So until you're confident with your hypothesis, you're going to want to test your points. So let's take this point and let's check it out. So it is negative 2 and 1. That is our point. So here is the value of the line. We have 1 is less than negative 2 plus 1. 1 is less than 3, or 2, positive 2 plus 1, which would be 3. So that is true for area C. And for area, for the parabola, let's check it. 1 is greater than or equal to negative 2 squared plus 4 times negative 2 plus 2. So negative 2 squared would be positive 4 minus 8 plus 2. 1 is greater than or equal to, be negative 4 plus 2, that'd be a negative 2. 1 is greater than or equal to negative 2. And that is true. So both of those equations just verify what my hypothesis was, which is that area C is the area. Let me make this a little bit smaller. And I'm just going to select that area. Now keep in mind that because this says equal, it's not just area C that satisfies this particular parabola, it's also the line. Okay. But the area of points that satisfies both is the line and this section of points. All right, and that's all we have for lesson 56. No, I take that back. We have one more. Sorry, I turned the page. Let me set it up and then we'll go through it. All right, so here we have a circle and a line in this system of equations. And we need to pick the point or the area of points that is true for both. So here I have that x squared plus y squared is less than or equal to 16. So I am going to look for those points that are less than 16. So that tells me that I probably need to look inside the circle, because typically inside is less than. but I don't know if it's the C or the B. So it's going to be B or C. And y is greater than or equal to x. That tells me that y is going to be above the x. So this is probably going to be area B. So let's pick a point in here. Let's just choose this point. I like to choose on the line if I can. So let's choose, let's see, 1, 2, 3. This is 0, 3. Just going to double check my guess that it is B. And for the line, 3 is greater than or equal to 0. So the line checks out. So let's try 0, 3 in the circle. So my x value is 0, so that's going to be 0. And my y value is 3, so that's going to be 9. 0 plus 9 is less than or equal to 16. And that's true. So this is true for this also. So both of them checked out. So section B is going to be the area that is true for both of these equations. And there you have it. So it's not hard. You just have to kind of look at the inequalities, try to make an educated guess on where you think the points will lie, pick a point, and test it for both of these. And if both statements are true, then you know that that is the correct area. If one of the statements is false, then make another hypothesis, pick a point, test it. All right, but you make an educated hypothesis, make an educated guess based on what these inequalities are telling you. All right, now that is all that we have for lesson 56. Make sure you took all of those shapes and illustrations down so that you can have a reference later, so that you don't necessarily have to figure it out manually every single time. That'll help you a lot. All right, I will see you in lesson 57.